Python versus Cpython. What's all this fuss about Python and Cpython, Jython, IronPython? I don't get it. Python.org mentions that Cpython is the traditional implementation of Python, nicknamed Cpython. Yet another Stack Overflow question mentions that Cpython is the default bytecode interpreter of Python, which is written in C. Honestly, I don't get what both of those explanations practically mean, but what I thought was that, if I use Cpython, does that mean when I run a sample Python code, it compiles it to C language and then executes it as if it were C code? So what exactly is Cpython and how does it differ when compared with Python, and should I probably use Cpython over Python, and if so, what are its advantages?
So what is Python? Python is the original Python implementation. It is the implementation you download from python.org. People call it Python to distinguish it from other, later, Python implementations, and to distinguish the implementation of the language engine from the Python programming language itself. The latter part is where your confusion comes from. You need to keep Python the language separate from whatever runs the Python code. Python happens to be implemented in C. That is just an implementation detail, really. Python compiles your Python code into bytecode, transparently, and interprets that bytecode in an evaluation loop. Python is also the first to implement new features. Python the language development uses Python as the base, other implementations follow. What about Jython, etc.? Jython, IronPython and Python are the current other implementations of the Python programming language. These are implemented in Java, C# and Python, a subset of Python, respectively. Jython compiles your Python code to Java bytecode, so your Python code can run on the JVM. IronPython lets you run Python on the Microsoft CLR. And Python, being implemented in a subset of Python, lets you run Python code faster than Python, which rightly should blow your mind. Smile. Actually compiling to C. So Python does not translate your Python code to C by itself. Instead, it runs an interpreter loop. There is a project that does translate Python-ish code to C, and that is called Cpython. Cpython adds a few extensions to the Python language, and lets you compile your code to C extensions, code that plugs into the Python interpreter.
You need to distinguish between a language and an implementation. Python is a language. According to Wikipedia, a programming language is a notation for writing programs, which are specifications of a computation or algorithm. This means that it's simply the rules and syntax for writing code. Separately, we have a programming language implementation, which in most cases is the actual interpreter or compiler. Python is a language. Cpython is the implementation of Python in C. Jython is the implementation in Java, and so on. To sum up, you are already using Python if you downloaded from here.
Even I had the same problem understanding how a Python, Jpython, IronPython, Python are different from each other. So, I am willing to clear 3 things before I begin to explain. Python, it is a language. It only states/describes how to convey/express yourself to the interpreter, the program which accepts your Python code. Implementation, it is all about how the interpreter was written, specifically, in what language and what it ends up doing. Bytecode, it is the code that is processed by a program, usually referred to as a virtual machine, rather than by the real computer machine, the hardware processor. Cpython is the implementation, which was written in C language. It ends up producing bytecode, stack machine-based instruction set, which is Python specific, and then executes it. The reason to convert Python code to a bytecode is because it's easier to implement an interpreter if it looks like machine instructions. But it isn't necessary to produce some bytecode prior to execution of the Python code, but Python does produce. If you want to look at Python's bytecode, then you can. Here's how you can. Now, let's have a look at the above code. Lines 1 to 6 are a function definition. In line 8, we import the dis module, which can be used to view the intermediate Python bytecode, or you can say, disassembler for Python bytecode, that is generated by Python interpreter. Note, I got the link to this code from #PythonErc channel, this URL. And then, there is Cpython, which is written in Java and ends up producing Java bytecode. The Java bytecode runs on Java Runtime Environment, which is an implementation of Java Virtual Machine, JVM. If this is confusing, then I suspect that you have no clue how Java works. In layman terms, Java, the language, not the compiler, code is taken by the Java compiler and outputs a file, which is Java bytecode, that can be run only using a JRE. This is done so that, once the Java code is compiled, then it can be ported to other machines in Java bytecode format, which can be only run by JRE. If this is still confusing, then you may want to have a look at this web page. Here, you may ask if the Python's bytecode is portable like Cpython. I suspect not. The bytecode produced in Python implementation was specific to that interpreter for making it easy for further execution of code. I also suspect that such intermediate bytecode production, just for the ease of processing, is done in many other interpreters. So, in Cpython, when you compile your Python code, you end up with Java bytecode, which can be run on a JVM. Similarly, IronPython, written in C# language, compiles down your Python code to Common Language Runtime, CLR, which is a similar technology as compared to JVM, developed by Microsoft.
This article thoroughly explains the difference between different implementations of Python. Like the article puts it, the first thing to realize is that Python is an interface. There's a specification of what Python should do and how it should behave, as with any interface. And there are multiple implementations, as with any interface. The second thing to realize is that interpreted and compiled are properties of an implementation, not an interface.
If you want similar, please consider subscribing.